we have tertiary alkanols, and we've been talking about primary, secondary, and today is tertiary alkanols. So we have to complete the classification today before we enter preparation of alkanols, how they can be prepared in the laboratory or industrial preparation and chemical properties. And today is tertiary alkanols. And the general formula of tertiary alkanols is R3COH. And I've always told you that R represents the alkyl group or the phenyl group. And look at this, that the OH is attached to only one carbon atom. And that is to say that H has no direct contact with the carbon atom here. This is very, very important in terms of their chemical reactions, in terms of their oxidation. You'll find out that it will be very difficult for tertiary alkanols to be oxidized because of hydrogen is not bonding directly with carbon atoms, unlike primary and secondary alkanols. We will come to that, just hold on. So it is just a tip of an iceberg, okay? So we have the R3 means we have 3 alkyl groups or 3 phenyl groups, and the OH is attached to only one carbon atom, carbon atom, okay? So I have few examples. We have a lot of examples of tertiary alkanols, but the most important thing is for you to know the general formula. If you know the general formula, you will be able to handle it at any cost. Okay, so let's see the first example of tertiary alkanol. The first examples I have today is 2-methyl-propen-2-oil. 2-methyl-propen-2-oil. So let's see why 2-methyl-propen-2-oil is a tertiary alkanol. Okay, so let's go. So we have CH3. Remember, we have the position of OL in 2. So we are going to have something like this. We have the position also, 2-methyl is also in this position. We have methyl group, then attached to the OH. Remember what happens here. We have the position of 2 here, methyl group, and we also have the position of OH, still 1, 2, okay? So propane, how many is remaining? I think 1, 2, then the last one is CH3, okay? This naming, you are not going to name the methyl group in brackets. It means that this is an alkyl group, okay? So if this position is confusing you, it simply means CH3, COH, CH3, 3. This is the same thing with this. If I am naming this, we are naming 1 or 1, 2, either way, 1, 2, it will still come into 2. 1, 2, 3. Or 1, 2, 3 is the same. So we are naming 1, 2, 3, or you can come here, okay? 1, 2, 3. So that is how we are naming it. So this simply means 2-methyl-propen, 3 carbon atoms, 2 oil. Okay? 2-methyl, 1, 2, 3, propen, 2 oil. This is the same as this, in case you are confused about this. So the most important thing here we are going to take home today is the tertiary alkanols. They have 3 alkyl groups. Look at what happens here. We have the first R1, we have here the second R2, and we have R3. So it has 3 alkyl groups that, tertiary alkanols. So this compound, the second one I have is 2-methyl-butane-2-oil. And somebody will ask me, why is it always 2-methyl butane 2-ol? That are the examples of tertiary alkanols. You cannot give any other thing that is not tertiary alkanols, you know. So this is one of the examples of tertiary alkanols. So let's go. I am using this structure so that for you to learn how, if they present it this way, you'll be able to determine. If they present it this way, you'll also be able to determine that. So we have our CH3, follow me. We have the C, we have 2-methyl position of CH3 position. I will also have the OH attached to it. They have 2 positions. 1, 2. We have CH2, butane. 1, 2, 3, and we have CH3. One should not be counted when you are using this kind of structure. This one in bracket should not be counted as longest carbon atom, okay? Because this one is telling you it is a group. So if you are to name this, we'll have 1, 2, 3, and 4. So now we will see that the position is OH, and also we have the position of the methyl group, which is also 2. So it is 2-methyl butane 2-ol. Okay, the last but not the least in my list is non-alkyl. The reason I decided to bring it for you to know that R does not only represent the alkyl group, R also represents the phenyl group, okay? This is the reason why I brought this. So this is simply C6H5 is the phenyl group, because if you remove one hydrogen atom from benzene, it gives you the phenyl group, okay? And this is 3OH. So of course we have 3 phenyl groups. 3 phenyl groups, and we have only 1 carbon atom. 1 carbon atom means it is methanol or met, okay? Methanol, we know. While ethanol is 2, so it is 1. So this is the phenyl group, and this is methanol. So this is tri-phenyl methanol. It is a tertiary alkanols or alkanol because it has 3 phenyl group, and the OH is attached to only carbon atoms. Bye bye, and see you in my next class where we talk about the preparation of alkanols. Catch you in my next class.